In the last lesson, we looked at how to use cross products to solve proportions. We're going to take one more look at that and follow up on a common mistake that people make. So here's a problem where we can use cross products so long as we're careful. We have this 4/13 equals the quantity a plus 4 over 39. When we go to apply cross products here, the first thing we're going to do is multiply 13 by the quantity a plus 4. That phrase, by the quantity, that means I have to multiply 13 by the whole expression, a plus 4. Not just 13 times the a, but times the plus 4 as well. We would write that down using parentheses to show that it's 13 times the quantity, a plus 4. This looks like the kind of a thing we would apply the distributive property to. Our other cross product is 4 times 39. And so we know that when we have a proportion, we can set our cross products equal to each other. On the left, we'll apply the distributive property. 13 times the quantity a plus 4 gives you 13a plus 52. And on the right, 4 times 39 is 156. Next, we'll subtract 52 from both sides. That gives us 13a equals 104. And then we're going to divide both sides by 13 to get a equals 8. Please be careful when you're doing problems that involve proportions. If any one of the expressions is a sum, in this case we have the sum of a plus 4, or a difference if we had a minus 4, be on alert that you may need to apply the distributive property when you use cross products. All right, next. Suppose I asked you to graph this equation. We have 3x plus 2y equals 8. And you remember from last year that equations where you have an x and a y together are linear equations. And when you plot all of the solutions to those equations, you get a straight line. So one way you might do this is you might make an xy table, and you might plug in a certain number for x, and then solve the equation for y. So for example, you might plug in a 1 for x, so you'd have 3 times 1 plus 2y equals 8, and you would solve that equation for y, and you would get that y equals 2.5. Then you would plug in a 2 for x. 3 times 2 would be 6, so you'd have 6 plus 2y equals 8, and you'd continue on. You'd repeat this a bunch of times for different x's and see what y values had to go with them to make the equation balance. This seems like kind of a lot of work. A second option you can do is you can solve the equation for y before you plug anything in. Solving for y just means we're going to get y all by itself. And to do that, we're going to apply the properties of equality. So to get the y by itself, first I want to get the 2y term by itself on one side of the equal sign. So I need to subtract 3x from both sides. On the right-hand side then, I have 8 minus 3x. Those are unlike terms, so I can't combine them. So I have the equation 2y equals 8 minus 3x. Now to get the y all by itself, I have to apply the division property of equality, divide everything on the left by 2, and divide everything on the right by 2. When I do that, my equation simplifies to y equals 4 minus 1.5x. Now I have the y all by itself. How does this help? Well, first of all, let's remember that these two equations, although they look very different, they have the same solutions. Remember that when we apply the properties of equality, do the same thing to both sides of an equation, we change the look of the equation, but not the solutions to it. So if I were to graph all the solutions to 3x plus 2y equals 8, and graph all the solutions to y equals 4 minus 1.5x, they would be the same. So how does having gotten the y by itself make it any easier to graph this line? Well, when I have an equation where y is already all by itself, the other side of the equation I can just drop in the x, and it very quickly spits out what the y should be. It's easy to drop in different numbers for x here because the equation is set up so that when I drop in a number for x, it spits out a number for y. We call this process solving for a given variable. In this case, the given variable was y. We solve for y, and now this equation is a little easier to use. So you can see I can quickly just keep dropping in different numbers for x, and the equation spits out what y goes with it. You will often see, both on your assessments and in your homework, a problem that asks you to solve for something. We'll do a lot of solving for x, and what that means is we're going to get x all by itself on one side of the equation. We'll have x equals something. Oftentimes, this is the process for solving an equation, x equals 2 or x equals 3. Anytime you see solve for blank, that just means get whatever that blank is by itself on one side of the equation. If you're solving for y, you're getting y all by itself on one side. If you're solving for p, you're getting p all by itself on one side. This may also be written as rewrite an expression so that y is a function of x. This is still another way of saying that we get y all by itself. It's a way of saying that we isolate y so that what's left on the other side of the equation is an expression that only depends on what number you drop in for x. So examples of equations that are written so that y is a function of x: y equals 2x plus 3. Again, I can drop in whatever number I want for x and it's going to spit out a y. Y equals x squared. Y equals 2.3x squared plus x plus 1. These are all written so that y is a function of x. The value of y clearly depends only on what I drop in for x. And it matters that the y is all by itself.